friends, welcome back to Maths On. This is Srivani Manikara. Today we are going to solve exercise 1.4 sums. Please do subscribe my channel as well as click the bell icon. Whenever I upload new video, you will get the notifications also. Without any further delay, let's get started. In this first bit, you have 5 sums. So first one is 1 by root 2. Prove that the following are irrational. To prove that, you will assume the opposite of it. So 1 by root 2 is a rational number. So let us assume on the contrary, 1 by root 2 is a rational number. We have known what are rational numbers. So we have known what are rational numbers. Rational numbers means in the form of p by q, where p comma q are integers. P by q are any variable you can take. So 1 by root 2 is a rational number. You can assume opposite of it. When you will prove that irrational, you have to assume that rational. So rational number in the form of p by q or a by b. Here 1 by root 2 is equals to a by b, where a comma b are integers. So the denominator b is not equals to 0. This we have known. So reciprocal of this 1 by root 2, reciprocal of 1 by root 2 is equals to root 2 by 1. Thus this equals to b by a. Root 2 is equals to b by a. Since a comma b are integers, so a by b or b by a in the form of rational numbers p by q. So root 2 is equals to b by a. Here we have known root 2 is irrational. So a comma b are here root 2 is irrational. We have known this root 2 is irrational number. So a comma b are integers. So a comma b are integers. B is not equals to 0 here. So b by a is rational. Root 2 is irrational number and also b by a is rational. So root 2 irrational is equals to rational. So it is not possible, it cannot possible irrational is equals to rational. So irrational number cannot be a rational number. Here we have assumed that 1 by root 2 is a rational, which is wrong. Hence we conclude 1 by root 2 is a 1 by root 2. Hence 1 by root 2 is a rational. Clear? Here see once again, to prove that 1 by root 2, let us assume that on the contrary 1 by root 2 is a rational number. These two steps are same for all sums. These two steps are same for all sums in this exercise. So you have to remember these two steps. Each step has some marks. So if you stop it here, you will get at least 1 mark. Now second one, in this first bit, second one, root 3 plus root 5, to prove that the following are irrational. So you have to assume opposite of it. So let us assume on the contrary. Contrary means opposite. So let us assume on the contrary, root 3 plus what is given, root 3 plus root 5. So given is a rational number. So root 3 rational number means it is of the form p by q. So p by q is nothing but a by b. Instead of p by q, I have taken a by b. So root 3 plus root 5 is equals to a by b, where a comma b are integers. You have known what are rational numbers. Rational numbers are of the form of p by q. Here a by b, we have taken a by b, where a comma b are integers. So the denominator not equals to 0. Here root 5 is equals to a by b. This root 3 is, I am taking this root 3 in RHS. So symbol will be changed, minus root 3. So LCM of these, B is LCM, A cross multiplication root 3 B. Okay, in this root 5 is equals to A minus root 3 B by B. Squaring on both sides. Squaring on both sides. So root 5 whole square is equals to A minus root 3B by B whole square. In this, wherever you have irrational number, that you have to take into LHS. So here 2 root 3 is irrational number. So we have to take this into LHS. Symbol will be changed. Clear? Now, here only I want root 3 in the LHS. The remaining I have to send other side. Remaining 2 into A by B I have to send. I am sending RHS. So here root 3 is equals to A square by B square minus 2. A by B, this 2 into A by B reciprocal of 2 into A by B. After going to RHS, it becomes reciprocal. So 2A by B is equals to B by 2A. So LCM of this, B square, A square into A square minus the cross multiplication of this, B square into 2, 2B square. So B by 2A. I am removing this bracket. A square minus 2B square by B square is B, and this 1B cancelled. So A square minus 2B square by 2A into B, 2AB. Did you get it? Are you getting? Root 3 is equals to B by 2A. So can this B by 2A, I am separating this and remove these brackets and write it multiplication symbol. B and 1B is cancelled, the other B is there. So 2A into B, 2AB term. This root 3 is equals to A square minus B square by 2 into AB, 2AB. In this being A comma, since A comma B are integers, so A comma B are integers, this is of the form of P by Q. So root 3 is rational. So root 3 is equals to this whole part is rational. Root 3 we have known, root 3 is irrational. So irrational number, irrational can't be rational. So our assumption is wrong. What is our, we have assumed that root 3 plus root 5 is a rational number. So irrational number can't be rational number. Irrational number can't be rational number. So our assumption is wrong. So root 3 is rational and root 3 plus root 5 also irrational. Root 3 is irrational. Sum of two irrational numbers also irrational. root 3 plus root 5 irrational. Understood? Here we have proved root 3 is equals to, here a by b is nothing but p by q form. So that is nothing but rational number. So root 3 we have known it's a irrational number. Irrational number can't be rational number. So root 3 irrational number and sum of two irrational numbers also irrational. So root 3 plus root 5 is irrational. Understood? Let us move on to the next sum. For all sums you have to follow same steps. Observe these steps. First, on the contrary. Let us assume on the contrary. What he is asking, prove that irrational number. So, for proving irrational number, let us assume on the contrary, opposite of it, a rational number. Rational number. So, root 3, rational number of the form of p by q, or here I am taking a by b. So, root 3 plus root 5 is equals to a by b, where a comma b are integers. B is not equals to 0. The same two steps that you have to follow for all sums in this exercise. Next one, sixth one, prove that 6 plus root 2 is irrational. So same steps we have to follow. Let us assume on the contrary, to prove 6 plus root 2 is irrational. Let us assume on the contrary, 6 plus root 2 is a rational number. To prove irrational number, we have to assume rational number. So, rational number is of the form of p by q or a by b, where a comma b are integers, b is not equals to 0. In this, here we want irrational number on left side LHS, so this one taking into other side a by b minus 6. 6 plus root 2 is equals to a by b. This is of the form p by q. So wherever you have irrational number, that you have to keep in LHS. The remaining 6 is taking into RHS. Symbol will be changed. So the LCM of this, LCM is b, a cross multiplication b into 6 b. Root 2 is equals to a minus 6b by b. This a comma b are integers. A comma b are integers and also 6 also integer. So 6 also a comma b and 6 belongs to integers, means a comma b comma 6 belongs to z. So this RHS is a rational number. So root 2 is equals to this total equals to rational number. Irrational number cannot be, so irrational is rational number. It cannot be possible rational. So it cannot possible. So our assumption is wrong. Irrational is equals to rational. Here irrational is equals to rational. So what we have assumed, on the contrary, 6 plus root 2 is a rational number. So root 2 is irrational. Root 2 is irrational. And also 6 plus root 2 is irrational. Here we have to write our assumption is wrong. Our assumption is, therefore our assumption, what we have assumed, our assumption is wrong. So root 2 is irrational, so 6 plus root 2 is also irrational. So given is irrational numbers. So given is irrational number, hence proved. Let us move on to the next one. Prove that root 5 is irrational. So let us assume on the contrary, root 5 is a rational number. Rational number of the form p by q or any variable. Here I am taking p by a by b. So squaring on both sides, squaring on both sides, root 5 whole square is equals to a by b whole square. So this square and root will cancel. So 5 is equals to, I am separating squares, a square by b square. 5 is equals to a square by this cross multiplication. A square is equals to 5 into b square. Let us consider a comma b are common factor and a comma b are co-primes. Co-primes means the common factor is 1. 1 is a common factor. So a square divides 5 and also a square divides 5, then a divides 5. So both a square divides 5 and also a divides 5. So here 5 is a common factor. Being co-prime, there should not be common factor. So a can be written in the form of a is equals to 5c. Here a is equals to 5c, a square is equals to 5c whole square, that means 25c square. A square is equals to 5 5 is 25c square. From equation 1, what is equation 1? A square is equals to 5b square. Here 5b square is equals to a square means 25c square. 25c square. So b square is equals to 25 by 5c square. This 5 taking into right RHS. So symbol will be changed. This is the multiplication symbol after going to RHS, divide. So 5 ones are 5 5s are. B square is equals to 5 into this c square. 5 divides 5. Here 5 divides b square and also 5 divides b. This common factor is 5. Therefore, A and B have both 5 as common factor. So A and B have 5 as common factor. So 5 as common factor, it's not possible. It contradicts the fact A and B are co-primes. But this contradicts the fact A comma B are co-primes. Co-primes means common factor. There is no common factor other than 1. So co-primes. So our assumption is wrong. So our assumption is wrong. Root 5 is irrational. This is a little bit lengthy, so listen carefully. Once again, prove that root 5 is irrational. So let us assume on the contrary. So these two steps are common steps for all these sums. So root 5, how can we write a rational number in the form of the form p by q? So here I am taking a by b. Any variable you can take. Root 5 is equals to a by b. Squaring on both sides, root 5 whole square is equals to a by b whole square. So 5 is equals to a square by b square. cross multiplication. After cross multiplication, a square is equals to 5b square. Here a comma b are co-primes. Co-primes is nothing but there is no common factor other than 1. So a square divides a and also a divides a. A square divides 5 and also a divides 5. A is equals to 5c. Here we are taking a is equals to 5c. 5c. Here we are taking a is equals to 5c for some integer 5. 5 is some integer. So a square is equals to squaring on both sides. A square is equals to 25c square. So from equation 1, what is equation? A square is equals to 5b square. So 5b square is equals to a square. A square we have to write it as 25c square. So b square is equals to 25 by 5 c square. 5 divides b square, 5 divides b. A and b, 5 as common factor. So, but this contradicts the fact a comma b are co-primes. Our assumption is wrong. So, root 5 is irrational. Let's move on to the next question. 3 plus 2 root 5. Let us assume. On the contrary, 3 plus 2 root 3 is rational. So we have known what rational. Rational number is of the form of p by q or a by b. Root 3 plus 2 root 3. 3 plus 2 root 3 is equals to a by b. So here we want only irrational number. On LHS, I am sending this 3 to RHS. So a by b minus 3. So b is LCM, a minus cross multiplication b into 3, 3b. 2 root 3 is equals to a minus 3b by. Here 3 plus 2 root 5 is rational. 3 plus 2 root 5 is of the form a by b, where a comma b are integers. B is not equals to 0. So 2 root 5 is equals to a by b. This 3 is taking into RHS. Symbol will be changed. So minus 3. 2 root 5 is equals to after doing LCM a minus 3b by b. So root 5 is equals to a minus 3b. This becomes 2 becomes reciprocal. So 2 by 1 is equals to 1 by a minus 3b by 2. So root 5 is equals to, since a comma b are integers. Since a comma b are integers, a minus 3b by 2 is rational. So these a comma b are integers. A minus 3b by 2 is rational number. So root 5 is equals to rational. Root 5 we have known, root 5 irrational. So irrational is equals to rational. The irrational number cannot be equals to rational number. So our assumption is, assumption is wrong. So what we have assumed, 3 plus root 5 is rational. So our assumption is wrong. 3 plus 2 root 5 is irrational. All are same steps. Last question of this exercise. Prove that root p plus root q is irrational where p comma q are primes. So let us assume on the contrary, root p plus root q is rational. Rational means root p plus root q is equals to rational. If it is rational, It is of the form P by Q or A by B. So here root P is equal to this Q is taking into other side A by B, symbol will be changed to minus root Q. Squaring on both sides. Root P whole square is equals to A by B minus root Q whole square. We should expand from A minus B whole square. We have known. So root and square will cancel. Then only P is equals to A square A by B whole square minus 2 into AB means this we have to assume A, this is as B. So into root Q plus root Q, B square means root Q whole square. This A square, I am separating squares. A square by B square 2 root Q A by B plus square and root cancel, only Q. So wherever irrational number that you have to take into LHS. So this minus 2 root Q A by B. 2 minus, after coming to LHS symbol will be changed. So minus will be plus. Q A by B is equals to A square by B square plus Q. This P becomes minus P after going to RHS minus P. So then root Q is equals to, this will reciprocal, 2A by B means B by 2A. A square by B square plus Q minus P. B by 2A, this LCM is equals to B square, A square plus B square, comma taking as common, Q minus P. So B and B square 1B cancel. So A square plus B square Q minus P by this 2A and B. You can write it as 2AB. A square plus B square into Q minus P by 2AB. Here taking B square as common. So A square plus B square into Q minus P by 2AB. This is all root. Here since A comma B are integers, A comma B are integers, it becomes rational number. So A square plus B square into Q minus P by 2AB is rational. Since A comma B are integers, B not equals to 0. So A square, this total is rational number. Since P comma root Q is equals to rational. So irrational is equals to rational. This contradicts root Q is irrational. Root Q is irrational, sum of two irrational numbers also irrational. So root P plus root Q are irrational. Root Q are irrational. Since P comma Q are primes. We have known here root Q is irrational, sum of two irrational numbers also irrational. So here sum of two irrational numbers means what? Root P plus root Q. What are P and Q? P comma Q are primes. So since P comma Q are primes, root P plus root Q are irrational number. Understood? So students, these are this essence of this exercise proofs. So you have to practice more and more. We'll see you next video.